Hello Amiga coders, this is Photon again, and I thought I'd continue on this demo and add something behind the logo, because right now it looks a bit empty. So what you see is the Sky logo, which I showed you how the hardware would do it most efficiently, and that is to have the hardware registers set so that there is as little DMA load on the CPU as possible. So the logo is 3-bit planes, and it's in a small rectangle on the screen, and outside that rectangle there's nothing. You have turned off the bitplane DMA. So that means, well, of course, if you turn off the bitplane DMA, then how do you add something behind it? Or I should say to the left and right of the logo and above and below the logo. Well, the answer is that you can't. You can add sprites behind it even though the bitplane DMA is turned off, but that's a trick that I don't think I'll show just yet. Besides, it's on English Amiga board, so just check it out there, and you can find out how to trigger the hardware to read sprite data specifically, even outside the bitplane edges. So there's a swath of bitplanes, 3-bit planes, where the logo is, and outside that we can't show anything right now. We can change the background color because that's always there. That's not read from DMA. But if you want pixel data, then we're stumped right now. So we'll have to change the copper back to allow that, and that's what I'm going to show in this tutorial. Also, below the logo is a bouncing scroller, which I've shown how to do in 2 different ways. For the scrolling, I showed how to do it with blitter scrolling instead of using the hardware scroll registers, which is not as efficient as using the hardware scroll registers. On the other hand, I showed you an efficient way of moving it up and down, and that is to simply change the position there. So there's a split in the copper just above the topmost position of the bounce of the scroller, and that will also have to be addressed in order to let something basically above the horizon there continue all the way down to the horizon without the interruption from the split. So let's have a look at the copper. So we've done it the correct way, unlimited DMA usage by inscribing the logo in a tight rectangle, and we've also shrunk down the screen edges with these values. So normally you'd go from like 2C to 2C. So what happens if we change that? That means that previously this vertical display window start was at 4C. So if we lift that up to fit a standard 320 by 256 screen, then that will lift the logo up. And we should check where we what we do with the bitplane control register. Here we turn all the bitplanes off. It's a good standard instruction to start the copper list with. Not really necessary though. And then we initialize the sprite pointers and some palette colors, and right here is where we turn on the bitplanes. And actually there's a wait just before that that will have to move or change to make it fit better. So what happens here is we want to set the palette and then turn on the bitplanes just in time for the start of the screen. And although the bitplanes are on, they will not take effect until the start of the display window that we've just raised up. So what happens here is we can run it first to check it, and the only effect is to lift the logo up by hex 20 or decimal 32 pixels, and while the instruction that turns off the bit planes at the bottom of the junk there, that hasn't changed, that hasn't moved up, so that remains in place. Whether you want the logo up top there or whether you want it on the same vertical position as before is up to you, but of course if you have to if you move it up, you have to also move the copper bar up. So in order to save that work, we'll put it back where it belongs. How do we do that? We need to have the bit planes on above the logo. And what does that mean? That means that we have to have some empty bitplane data there, which is not very efficient, but when you compress the demo, it will compress it away, the blank space. So that's my excuse anyway for reverting from the previously optimal DMA optimal copper to something that we can use, or rather make more interesting. So one of the problems I see here is that it waits for our changed display window start position of 2C, raster-line 2C, and then sets the background color and all the other colors for the logo, and then it enables the bitplanes. That's not entirely correct. What we want is for the bitplanes to be turned on in the border, or before, at a horizontal position where it's safe to do so. Actually, it's safe at any time before this position, because not until the hardware hits the display window vertical start will this value take effect. So that's corrected. Now we need to basically redo the logo, and we have to convert it again. So what you do then is, we want to also display stuff to the left and right of the logo. So obviously, if we in a previous tutorial we removed the smiling face sprite there, and now we're gonna replace it with something else. So let's enable it again and see what's going on here. Here's the code to move it, so let's put that back. That should move the sprite. It's now called dummy sprite because we did a 1 pixel high dummy sprite to have something there, and later we set that pointer and clear the other pointers to a null pointer, which is basically a null sprite, which is basically a dummy sprite. So if we go to the dummy sprite and we change this to all ones, to use whatever color is sprite color 3 or palette color, let's hang on, 19. Obviously, if we do that, we should get a line, but this is at a vertical position outside the screen, so it will not be shown. We will have to move down to a position that is lower down than hex 2C, which is the display window vertical start. So if we go 3A instead and run the demo, we should get a moving sprite on the screen. And there it is. And as you can see, it strangely starts at the display window left edge, but continues all the way to the right edge, and that's an OCS feature that can be used for tricks and stuff. However, in order to get it to display to the left of the logo, all the way out to the left margin, like the scroller, then we have to widen simply widen the logo graphic that's being displayed. So what you do then is, well, we have to check. I can demonstrate. Well, I'm not going to do that now. I'm just going to set a jump pointer there. So anyway, here's where we are, and here's where we add a margin. We don't want to do that. What's going to happen is, if we remove this, we're going to get a full width DMA fetch window, and that'll help us out. The logo will be garbage. Well, it will be displayed with the wrong modulo at least. And this will be corrected by setting the new dimensions of the logo with the wasteful empty bitplane data around it, and that will then display the sprite all the way to the left margin. Let's check that out. Disregard the logo modulo error there. If you get something like this, then you know it's a modulo error. You get something that looks like blinds in a window, or an incorrectly interleaved picture. So now that that's fixed, we need to get the dimensions that we should convert. So let's check it here. So previously it was 4C, so we've increased the height by hex 20, and we have increased the width by logo margin times 2. So that was pretty easy. So basically what you need to do is change this to 320 full width and add 32 to the height. So that's 99, right? And that should fix us. However, it will still not be magically correct, obviously. It will just be a different modulo and the pointer will go out into the memory and fetch everything that's after the logo there. But let's save there temporarily, and alright, so I'll fire up Deluxe Paint and open the original file. And what we need to do is to move this up to 32 pixels below the top edge and keep the centering. So we'll just turn on coordinates so we see what we're doing. So coordinates, origin upper left, and let's just put a pixel there. Make sure that you scroll up, because sometimes the picture is a part of the picture is hidden below this. Shouldn't affect the coordinates though. So there we go. That's where we want the top edge of our logo, so why not move that to there. And I do this to move things strictly vertically. I hold shift, right click, move it up, and there you go. So this is now centered. We need to reduce the number of bit planes. So screen format, only 8 colors please. And we're going to save that to centered. And convert it back. I'm sorry about these typing errors. I'm using a mic that is standing between my eyes and my keyboard. And don't forget the slash, and we called it sky centered 3. And let's load that up. Obviously not. Sky 3 centered. There you go. So there's a decision to make here. Should we cut this out to just the lowest line there, or should we let it continue on? Basically, you need to know how many more lines of empty data you need for the rest of the stuff. But we can actually do this with some trickery. So I'm gonna cut this out and leave one line of empty space below the logo. I will show you why later. So this is now a bit of a wasteful logo, but it will allow us to make relatively easy changes to the copper list and have stuff behind the logo or in front, as the case may be. So I'm going to call that sky4.raw. Logically, no, must be centered raw. That's it. So let's just do that and save it. So this is now centered, and we check that we increase the dimensions. This height is now incorrect, but it doesn't matter because we have that split to take care of. So that's our logo back. I have no idea if it's centered or not, but we can take care of that with the scroll register if necessary. So now you can see that the sprite goes all the way from the left edge all the way to the right edge. So one of the requests was to make a Starfield out of this. So how do you do that? Well, sprites can be... we should change the name of the sprite. Dummy sprite to star sprite. Do that globally, and well, we were right there. Star sprite. Let's go ahead. I'm sorry, no American expressions here. We will still have 1 pixel high sprites, but we can now lift this up to hex 2C and end it on hex 2D. So, and we can set this to be a color combination that sets a bit, the highest bit in this case, for the first bit plane and nothing in the second bit plane of the sprite. These words work just like if you had 2 bit planes displayed on screen. So it will take this bit and add, give them different weights and add them together to get a palette color, in this case from the sprite palette, which starts at color 17. So this will set a pixel with the color 17 using color 17, the color 17 register, so named in the custom chip registers, and that'll give us a dot basically. But here's the thing: you can, instead of these empty control words, which are just like these control words, only containing zeros, you can continue this sprite vertically and give each sprite different control words, meaning that they can have, in the case of Starfield, they can have different horizontal positions. So if we copy this and copy that, but we make this color 0, this color combination color 18, and do the same again, and make it the third color in the sprite palette. That means that we get 3 dots, but we have to change the horizontal position here. So this is outside the screen, and this X horizontal position, if you check this meaning here, so that's the horizontal start position of the sprite divided by 2. So if we start out displaying them on the screen, we could put them like 5.8, 5.9, and 5A, like that, and they should be displayed. The only problem is this sprite ends at hex 2D, and then comes a vertical position that's higher than that. That's not possible. You have to sort the sprites vertically. So we would like the next dot to be on 2 pixels down. Certainly 2D or 2C are not valid values for this. So that will continue like this, and this will then be 3.0 and 3.1. So that should give us 3 dots, of which 1 is moving, basically. So you can see there that we have a light blue dot moving. We also have a black dot and a sort of a red dot there. So the reason why only one of them is moving is because this only adds a value of 1 to the first sprite control word. But we have now followed it with 2 more control words for the following 2 dots. So that means that if we do this, and now we have to figure the distance here. We could number them all, but it would be a tall order, long job. So we'll add an offset. So depending on the height of the dots you want to use for this Starfield effect, then whether you want the stars to be 1, 2, or 3 pixels high, something like that, the offset will differ. Here we'll use only single dots, I think, or at least stars that are only 1 pixel high. So we have to, so this pokes a control word that's followed by the actual pixel data, which is then followed by another control word. Another control word pair, I should say. So each, so to speak, pixel line of the sprite is 4 bytes, and they're spaced 2 pixels apart, so 2 times 4. So this will add an offset of 8, and this will add a distance of 8 times 2, and so on, to continue this. So what happens then? Then we should have like a small cluster of stars moving. And I don't know, I have no idea if you can see this on YouTube, but I've made efforts to improve the video quality. I hope you can see it. So let's make those colors bright white, just for demonstration purposes. Actually, let's make them like white and then fade them into the background, because that's a good idea for Starfields. So that means we have to check the copper to see if it sets the sprite colors at all, or if they're just left at these random values here. So what you want to look for is 1A2, for example, which is color 17. So these are our sprite colors. It should say sprite colors, bad coder. So let's say that I want this to be white, and for simplicity we'll just put that there and then add some blue. See how that looks. So now they're like three different colors of the sort of the same hue. The darkest one is a little bit too dark, I think. So let's do them like, I don't know, 99B again, 99B. And let's make this one something like that. So that looks all right to me. So those are the colors set, and now in order to make a Starfield out of this, you only have to change the speeds. Note that if you don't change, if you don't toggle the last bit of the first control word pair, which sets the lowest bit of the horizontal position, then the speeds will be 2, 4, 6, 8, etc. So for simplicity, you can do this as an exercise, but for simplicity, I will do as many a crack intro coder has done and use three different values. So this was the dark dot, and that moves slowly. This was the medium dot, and it moves medium. And this was the bright dot, and it's supposed to look the closest being the brightest, and so it moves the fastest. So now we have a mini Starfield. And again, I don't know if you can see this on with a video codex on YouTube, but anyway, I assure you that they look all right on my screen. So where do we go from this to make this a Starfield? Well, you could just copy and paste these lines a bunch of times, and copy and paste the Sprite data words and control words a bunch of times to make it a sprite that is as tall as the screen, and move them all at predictable speeds. But why not make it a loop for now at least, and use the repeat statement to create the initial control words. So let's do that for the sprites first. And here's where they are. And basically you could just repeat these a bunch of times. Of course, the screen height may not be divisible by 3. But in general, you would do this. And also, you would perhaps want the further stars to be overrepresented in that if you were moving through a Star Trek, the original series from the 60s type of science fiction depiction of traveling through space, then of course, if you traveled through space, the stars wouldn't move. You wouldn't move fast enough relative to the star for them to move. But let's pretend it's a snowflake storm or something. We're after the illusion. So what we can do is we can make this slightly wider, and you can check the code for this. Makes this fast, bright star 2 pixels wide. Still only 1 pixel high though, because it simplifies matters. Now, to overrepresent the slowest stars, you can simply do like this, and these values don't really matter, because you will have them initialized before at the first vertical blank interrupt, and you will fill in the vertical values with a loop, and also these will start with some kind of random value that will invent adlib. So anyway, this means that we have a dark star, medium star, dark star, bright star that is 2 pixels wide, and that should be sort of a good mix. So the screen height is divisible by 4, so 256 divided by 4 is 64, so we repeat this 64 times. And this then becomes one entire sprite. Not quite true, but true enough. It becomes an entire screen high sprite channel that gets reused every 2 lines. So again, go back to where we had these poke statements and write a loop. So I'm going to do this 64 times 2. Hang on. Why doesn't this work? Okay. Oh, because I didn't put it in a data register. Alt Enter gives you a loop, and what you want to do is replace this with perhaps 1A0, A1. Let's use register 1, and let's do this. We also have to add another one here, and we have to change this to a slow speed and this to the fastest speed, and because we had 4 lines, remember, we overrepresented the slow stars. That's why it's 4 now instead of 3. And let's do that, and let's do that, and let's do this. So this has replaced the original instructions to move the sprites in a sort of parallax way, at different parallax speeds, to create the illusion. And we need to set the pointer to the base pointer, and we repeat this 64 times. But we have not set the vertical positions. So the vertical positions should start at the top of the screen, right? And we want, for each sprite, we want it to set the vertical start and stop of that sprite. So what we'll do is we'll change all these to add quick, because it's wasteful otherwise. And this changes the second byte of the control word pair. We want to set the first and third bytes simply by moving an increasing counter to those registers. And we want to increase the counter by 1 before we, do that poke. So as you can see, we write to increasing addresses using byte operation size all the time. That means that we can in fact use the post decrement notation here and save a few cycles. So let's do that. So that's how writing to one sprite will look. And then we have to skip the last byte. Actually, we're not going to skip it. We're going to check the highest bit of D0 and set the vertical start and stop high order bit for it to work. I will do that later. I will demonstrate this and show you how it looks. It may be though that it will get confused and we'll get running sprites, but let's check this out. And basically all we have to do now is to keep going, and we can add this instruction to skip a few bytes to the next sprite control word here. So we've increased it 3 times. In order for it to jump 8 bytes to the next control word, we add 5 to the pointer. And after that we can just copy and paste 4 times and just change the speeds, the horizontal speeds. So I wish I had commented the code, because now it looks rather anonymous, efficient but anonymous. So let's do that. Restart. And we also have to, because they're spaced 2 pixels apart, we have to increase it afterwards as well. So after each write of a vertical start or stop position, we increase the vertical counter. So that's us, and we're gonna like that, and let's check this out. Well, first of all, you don't add bytes to an address register. Words are fine, long words are fine. Both become long words, but add quick.byte does not work. All right. So that's our Starfield effect right there. It does seem to get a bit confused, but above all, it looks way too regular, doesn't it? So we need to jumble up the actual horizontal starting positions, and we can do that with in the original data if we want. We could also make an initialization routine to do it for us one time. So what we'll do is we'll ad-lib some pseudo random value that I hope will look correct, and use local variables to make some multiply and divide. So .x, why not? Don't set the seed to 0, set it to something interesting. I don't know. Then we'll need a temporary x that will be the random value. Calculated from the seed. And I have no idea. Let's try something like I don't know, 7 is a good value. All right. We can change these to make it look all right. Maybe it'll simply never look good, and then we'll just have to live with that. But anyway, that's our temporary X, sorry. And that goes in, that is recalculated for each dot. And we also need to transform this somehow. So we'll do this here, and here, and here, and here. And we'll set it. We'll replace this. And actually we need to fix this. Hang on. So that it stays within 0 and 255. And that's what goes on here. So that's our code. And as I said, we can copy these because we set the vertical positions in the loop. Hang on. There you go. And we need to set it before we poke it. And for each time we need to I don't know, 11, 117, I have no idea. So keep that within the word, let's say. I'm just winging it right now. So there you go, that's our sprite generation routine. So let's save that and see how that looks. Well, it's still pretty, you can see that it repeats every few lines, but you can play around with the numeric values and see how it works. Our basic problem right now is that the stars are in front of the logo. I don't know if you dig on that, but that's just sprite properties, so let's go ahead and see how those affect things. Let's see if we have set them already. Doesn't seem so. That's not good. So let's go ahead and do that. Sorry. Let's do that here. See what happens. And that put them behind the logo there. They're still gonna be in front of the copper bar, but let's hope nobody notices. You can also put them in front by doing, I think it is 36 or hex 36. Yeah, let's say it's decimal 36. So that's how you change the properties. So let's so now we have something behind the logo. So I'll end this tutorial here, and hopefully in the next episode we'll have more interesting star generation constants, and I will I would like to add that we were kind of saved here because We were saved by the vertical split, or rather by the horizon there. What do you want? Maybe we want the stars to be reflected below the horizon, but as you can see, where the where the floor is, and below the horizon, there are no stars, and that's because we've wrapped around. We started at hex 2C right here, so that means that we will hit hex FF before we reach the horizon, and that confuses the hardware because we haven't set the most significant bit of the vertical sprite position correctly, because that is still left right here. It's still left as 0 right here. So that's a good exercise for the next episode. See you next time. Bye bye.